So let's talk about what units scientists use when they are conveying their measurements. There are 7 base units that scientists use, and all other units are based off of those 7 units, those 7 base units. So for length we use meters, mass we use kilograms, time we use seconds, temperature we use Kelvin, amount of a substance is measured in moles. In physics, you may need to measure electric current in amperes and luminous intensity, like how bright a light is in candelas, but we won't use those last 2 very much in chemistry, but we'll certainly use the first 5. So let's look at those in a bit more detail. So these SI units, these Système International units, we base the abbreviation off of the French. Scientists all over the world have agreed on this single system of measurement, and these SI base units are the fundamental units of measurements. Now, the tricky one for students to remember a lot of times is that the kilogram is the base unit for mass. And the reason we use the kilogram is because grams are just too small. A paper clip is a couple of grams. And since our other base units are larger, like a meter, there's nothing a meter long that only weighs a gram. So we use kilograms as more on the right scale to match the meters. So that's why scientists use kilograms and not grams as the base unit for mass. Mass is a measure of the amount of matter in an object. It does not change with position, so it doesn't matter where you are in the universe. That is different to weight. Weight is a measure of the force of attraction on an object due to gravity. And therefore, weight changes depending on where you are in the universe, depending on how strong the pull of gravity is. Other base units. The base unit for length is a meter. That's about the width of a doorway. Time is measured in seconds. Temperature is measured in Kelvin, not degrees Celsius. The reason we measure temperature in Kelvin, not degrees Celsius, is because the 0 Kelvin actually has real meaning in the universe. 0 Kelvin is absolute zero, where all particle motion stops. And so the Kelvin system is based off of something that has universal meaning as opposed to degrees Celsius. Degrees Celsius is based off of the freezing point and boiling point of water, which is handy for humans. We like water. It's important to life, but it doesn't have the same kind of universal application as the Kelvin scale has. Moles measures the amount of a substance, and a mole is kind of like a dozen in that it's an assigned number. So if I tell you I have a dozen donuts, you know I have 12 donuts. And a mole is a similar quantity. It's just a lot bigger than 12. It's 6.022 times 10 to the 23rd, if you're curious, but we will get to that later this year. So every other unit that you might use in science is derived from those 7 base units. For instance, area is length times width. Well, length is measured in meters and width is measured in meters. So area is going to be measured in square meters. Volume is measured in by doing length times width times height. Those are all measured in meters. So the derived units are meters cubed. Density is mass divided by volume. So you do kilograms for the mass, and volume is meters cubed, and you end up with kilograms per meters cubed. We'll get to molar mass later in the year, and concentration and molar volume. Energy is one that we will talk about. Energy, the units are joules, and it doesn't look like it's a derived unit, but really it is. Force is mass times acceleration, so that's kilograms times acceleration, which is meters per second squared, and then length is also meters. So when you put that all together, the units for joules are actually kilograms meters squared per second squared. That's a big clunky unit, so scientists came up with an abbreviation for it, joules, because it's shorter to write. But my point is that every other unit you might use in science class is derived from those 7 base units that I showed you previously. We'll look more at derived units later. This was just a brief overview to contrast base units from derived units. Let's go back to those base units for a second. I told you that the base unit for temperature was Kelvin, but usually we don't measure things in everyday life in Kelvin. We're more likely to measure things in degrees Celsius. And so in order to convert between Kelvin and Celsius, if you have a temperature in Celsius, you add 273 to it to get the temperature in Kelvin. Or if you need to work in reverse, if you know the temperature in Kelvin and you want to find out the temperature in degrees Celsius, you do the Kelvin minus 273. So 273 is this is the number that you need to add or subtract in order to convert between Kelvin and degrees Celsius. Now, one thing that might help you make sure you're going in the right direction. Kelvin temperatures can never be negative. 0 Kelvin is absolute 0. You cannot get colder than that. So just keep that in mind when if you can't remember whether you should add or subtract. Kelvin can never be negative, but degrees Celsius can be negative. A negative temperature in degrees Celsius just means you're below freezing. Please, when you're doing these problems, don't use the internet. The internet will tell you 273.15 is the conversion factor to use. If I see that on your paper, then I'm going to assume that you use the internet instead of your brain to answer the questions, and I will mark it wrong. So use 273, not 273.15. So let's do a couple of practice problems. So you can pause the video and then come back and check your answers to see if you've done these correctly. So for number 1, how do we convert from 34 degrees Celsius to Kelvin? Well, if I subtracted 273 from 34, I would have a negative number as my answer Kelvin. So that's definitely not what I want to do. To find out the temperature in Kelvin, I'm going to do my degrees Celsius, which is 34, and I'm going to add 273 to it. So when I add those together, I get 307 Kelvin. Always include your units. For number 2, again, I'm going from Celsius to Kelvin, so I'm going to have to add 273. So I have 101 plus 273, and I get 374 Kelvin as my final answer. For number 3, this time I'm going the other direction. I'm going from Kelvin to degrees Celsius. So to figure out my degrees Celsius, I start with my Kelvin, and I subtract that magic 273 number, and I get 102 degrees Celsius as my answer.